about the power rule. So if we have x to some power, sorry, this is my n with 2 bubbles, and this is my m with 3 bubbles. Sorry about that. When we want to differentiate, find the derivative of this function, all we need to do is bring down n and subtract 1 from the power. Now, I would like you to remember the following rule. What if n is 1? Then I have x prime. I bring down 1. We normally don't write 1. And subtract 1 from the power. 1 minus 1. So how much is x to 0? Assuming x is not 0. How much is 5 raised to 0?
1.
Exactly. So then this is 1. So please remember, moving forward, x prime is 1. So now if I ask, let's say we have a function that is 3x to the third minus 4x squared plus 2. And we want to find f prime, and we don't like this method. Nobody likes this method. Look at how many steps. This is a complicated situation. No, I want to use the power rule. So I have to differentiate this. According to the power rule, I bring down 3, but I have to multiply it by this 3 in front, and subtract 1 from the power. This part is done. Bring down 3, multiply by 3, get 9, subtract 1 from the power. So I'm using the power rule. Can anyone give us the answer for, not the last one, we have to discuss the last one, but can anyone give us the answer for this? We are differentiating this.
Minus 8x.
Minus 8x. And now, this is very important to remember, but now I'm asking you, what is a constant? A constant prime. What is the rate of change of a constant? You have $2 in your pocket. You do not add money, you do not subtract money. What is the rate of change of these $2? How much they change if you don't add, you don't subtract? What is the rate of change? 0. The rate of change of a constant is always 0. None. No change. A constant prime is 0. So therefore, this constant prime is 0. Look how elegantly and how easy and how fast we determine the derivative using the power rule. And I didn't tell you, but we also use the addition and subtraction. So when I differentiate a sum of functions, I differentiate each one individually. Okay, now let's, yes, I see a chat. Is it for me? You were probably too late. That's probably why. I'm not sure. Okay, so let's look at, where is my page number? Page number for this is 154. 154. We want to choose. We want to differentiate. We want to choose. Anything you'd like to find a derivative for. Of course, some of them require work, more work. These are very simple, but these require some work. Not this one, for example, but okay, this is another notation. It's the same thing. So if we write find f prime of x, or the derivative of y, which is f, with respect to x, this is the same thing. It's a different notation. This one is called the Leibniz notation. So just remember, they mean the same thing. Okay, so let's choose. This is exactly the same thing. So we are asked to differentiate these. Would you like to choose, or I will? Okay.
36.
36. Very good. 36. Let's start with 36. In 36, we have f of x equals 4 over 7x cubed. Good pick. Well, remember simplifying, factoring, these are keywords. I don't know how to differentiate this, but I do know that this is the same with 4/7 x to which power? Anyone? Which power should x be in order to go back to the denominator?
Third power.
But if I put power 3 here, I cannot bring it to the denominator.
Is it a fraction?
No, unless it's a radical. If it's a radical, then it's a fraction. It's a fraction only when it's a radical.
-3.
Yes, please remember we reviewed this property. So now I can differentiate. So let's find f prime. Bring down -3 and multiply by 4. -12 over 7 times x, subtract 1 from the power. What do we get? When we subtract 1 from -3, what do we get? You owe me $3 and I give you one more. How much do you owe me now? Is anyone?
4.
Yes, of course, -4. This is it. Yes, you can continue and now you can bring it back down. -12, 7x to the 4th. So this function gives the derivative or the rate of change or the instantaneous rate of change of this function everywhere where the function is. What is the word? Where the function is? How do we say that? Where the function is differentiable. Where the function is differentiable. Okay, moving on, other examples. Let's look at 37. 37 has f of x equals 4 over x minus x to 3/5. We want to differentiate, so let's find f prime of x. Now, this is not a difficult situation, and I would like us to remember. As we remember that x prime is, how much did we say? What did we say that x prime was? Equal to?
1.
Yes, and the constant, any constant prime is?
0.
Excellent. I would like us to remember that 1 over x prime, and I'll show you in a moment why, is -1 over x squared. So please carve these in stone. Okay, so let's take a look. 4 or 1 over is the same thing. So let me just show you 1 over x. 1 over x is the same with x to -1. We have to be able to go back and forth. So now when I differentiate x to -1, the power rule says bring the power down and subtract 1 from the power. That's how we get this, -1 over x squared. Please remember this is a very important function. So now can anyone differentiate 4 over x? Not 1 over x. Same thing. 4 over x prime, what will we get? Can anyone tell us? 4 over x prime will be negative what over x squared? Anyone? Please try. It's okay if you're wrong. Please.
Negative 4 over x
Of
squared.
course, that's it. Now let's carefully differentiate this piece. I have to bring down the power. And now I have to subtract 1 from the power. So 3/5 minus 1. I have to find the least common denominator, which is
5.
exactly. And this one needs to be multiplied by 5. How much is 3 minus 5? 3 minus 5.
Negative 2.
Excellent. And this is what I have to write. Negative 2/5. This is not a very nice function, but that's what it is. We differentiated this piece to get this. We differentiated this piece to get all this. We brought down the power and we subtracted 1 from the power. 3/5 minus 1 is negative 2/5. Yes, you can bring it down if you want and write it as a radical if you want, but that's good enough. Now, here's the question again. Why am I doing this? Who cares about f prime? Why am I caring about f prime? Because f prime will tell us whether a function is increasing, whether a function is decreasing, whether the rate of change is positive, the rate of change is negative, and so on and so forth. A lot of information comes from f prime. That's what we're looking at f prime. Otherwise, nobody would care about it. But we do care about it because it tells us a lot about a function. Okay. So we can continue with other functions. So let's choose another. Anything that you would like to pick from here, please? Anything. Of course, these are not friendly situations, but we have to look at them. Here we're given a function and we're asked to find the derivative and then evaluate it at negative 2.
We do whatever you think is most difficult.
Yes, but I'm not going to test you on most difficult because I'm not trying to test endurance. I'm trying to test understanding.
Right. I always feel like we always, not specifically in this class, but I always feel like whatever we do in class, we always get like much harder stuff on tests and homework.
Oh, that's not my case. But that's fine. Please, you choose. Please choose. Anything you want.
Whatever you think is most difficult. You know better than I do.
So what I would like
That's relevant, at least.
Okay. So what is relevant, for example, is, for example, 51. So let's look at 51. In 51, we have y equals x plus 2 over x to the third. And we're asked to find, and this is dy over dx, and this is how we write it. Find dy over dx, a vertical bar, and towards the bottom, I'll stop sharing in a second. So there are two different notations. If I use the notation f of x equals x plus 2 over x to the third, very simple, I will say f prime, find f prime of 1. So this is one notation. If instead of f of x, we use y, then we tend to ask dy over dx evaluated at x equals 1. Of course, this is a much easier notation than this one is, but we have to get used to both notations, and you'll see later on why both are important. Okay, now this has to be changed into something nice that I can differentiate. Can anyone tell us how to change that? X plus 2 times. X plus 2 times what? Anyone? We did a couple of examples already. So what is this?
Is it negative
You
1
mean,
over negative x?
you mean x to negative 3. So one more time. 1 over x to the third is the same with x to negative 3. 1 over x is the same with x to negative 1. So please carve this in stone. This is not part of this class, but I review it and I review everything with you. But please remember, it's not that difficult, right? So 1 over x cubed is x to negative 3. This is very important to remember because I will have difficulties. I make my life easier if I do this. Okay, so then can anyone help with dy over dx? dy over dx or f prime? But we are using the Leibniz notation, dy over dx. Can anyone differentiate this function for us? And I will write it here. Give it a try, please. It's okay if you're wrong. I'll help you. Can anyone differentiate x for us and give us the answer? Please, can anyone differentiate x and give us the answer? Anyone, please? Julia, do you want to try? Can anyone give us x prime? Am I muted?
No.
Okay, so can anyone give us x prime? Are we on strike? We're going to spend the night here before, we're not going to leave before somebody tells us x prime is what? I'm kidding. So can anyone tell us what is x prime?
One.
Thank you. Can anyone multiply these two and tell us the answer?
A 2 and a negative 3.
Good.
Negative 6.
Very good. And times x to which power?
Negative 4.
That's it. That's all I needed. Awesome. Finally, I want to plug in 1. How much? How much is 1 to negative 4? It's 1 over x to the fourth, but it's 1 over 1. So the space is 1. Right? X to negative 4 is 1 over x to the fourth, but when I plug in 1, I have 1 over 1. So how much is 1 minus 6?
Negative 5.
That's it. Awesome. So we are advancing